Greetings and welcome to the pilot episode of my new video blog series, OpenShift Outdoors. I am your host, Charu Groover, and today I'm going to be walking you through one of my absolute favorite components of the OpenShift ecosystem. If you're not familiar with Red Hat OpenShift, OpenShift is a Kubernetes distribution that is designed for the enterprise. It comes out of the box with an opinionated security posture, extra tooling that is both operator as well as developer focused, and a whole ecosystem of additional components that can be installed through the operator framework. In this particular demo, I'm going to walk you through one of those operator installed components called OpenShift Dev Spaces. What Dev Spaces is a cloud integrated developer environment, okay? And so before those of you who are developers, roll your eyes and turn off your browser. Yes, this is a IDE in the cloud. It is exposed through the browser, but bear with me because I'm going to show you, I think, how this solves a lot of problems that are productivity killers for you in your day-to-day work life. This is the solution to what my friend Jim calls the $500 laptop problem. And if you're in a typical enterprise and you're an application delivery professional of some sort, either a direct coder or working with coders, delivering applications that provide business value to the company that you're part of, you've experienced this problem. So you're in a cloud native environment for your production workloads, which means it's a Linux-based ecosystem. If you're using Kubernetes, hopefully OpenShift, because I might be a little bit biased, but it is the best. It's a Linux environment, right? It's running Linux containers. And yet, the tool that you've been given to write your code is, in all likelihood, a Windows-based laptop. And yeah, that Windows-based laptop could probably use some more CPU. It could probably use some more RAM. But that's actually not the worst of the productivity killers that you have to deal with. You likely don't have administrative access to that workstation, right? And so any software that you need, any tooling that you need, you likely have to depend on someone else to install that for you. The other challenge is that you're not just working on a single code base. You're probably responsible for or occasionally have to work on multiple code bases for applications, some of which were written a decade or more ago, and some which are greenfield and brand new. So in addition to the fact that you're working on an operating system that does not match the target runtime for your apps, and you don't have administrative abilities on that workstation to install the tooling and the software that you need, you also have to juggle between different versions of the tooling and the capabilities, right? You got to flip between JDK 8, JDK 11, JDK 17, JDK 21. You might have to be switching from a really old Node 14 all the way up to a Node 20 and every LTE release in between. Additionally, the applications that you're working on don't run in a vacuum. They depend on other collaborating components, right? So you might need a Postgres database, you might need MongoDB, you might need a Kafka broker with topics that you can do event-driven communication between various microservices or function as a service off of, right? And the challenge of running all of this on your local workstation, juggling the various dependencies, switching between the various versions of things, all impacts your ability to write and deliver functioning business code. Well, OpenShift Dev Spaces solves that for you. It solves it by giving you what is effectively a bookshelf full of laptops. Imagine this for a minute. You got a bookshelf full of laptops. Each laptop on that bookshelf has been precisely provisioned for a given application ecosystem that you might need to work on. So it already has the tooling. It already has the collaborator components like the Postgres database or the MongoDB or whatever you might need. It has the right versions of the runtime components of Node, of Python, of Java, everything that you need to contribute code to that application ecosystem is on that laptop. And right next to it is another laptop that is precisely provisioned for yet another application ecosystem. And so when you need to work on one of those, maybe it's a bug fix, it's a hot fix, and you got to do something real quick and get it done, and then be done with it and go back to the greenfield app that you were working on. Instead of having to fight with your local workstation of switching versions of things, you just grab that laptop off the bookshelf, boot it up, do the code, get real-time feedback of the code working, verify that what you wanted to see, you are seeing, commit it, close the lid, put it back on the shelf, pull the one you were working on off the shelf, open it up, and get back to what you were working on. That is OpenShift Dev Spaces. And that's what I'm going to show you now. So what you're seeing in front of you is an OpenShift cluster. I have the OpenShift Dev Spaces components installed. They are installed via Operator Framework, and so they take advantage of all the role-based access control, all of the security configurations that are part of your OpenShift ecosystem, and participate in leveraging the OIDC or OAuth that you have set up for that environment. So as a developer, to get to OpenShift Dev Spaces, I log in with my credentials. And when I log in, it's going to throw me in a dashboard. That dashboard is the bookshelf I was talking about. That's over here on the left-hand side. It's also sitting right here in front of me on the main screen. Each one of these workspaces represents one of those laptops on the bookshelf that is configured for a particular project ecosystem. I've already set these up and have them installed. In some future videos, I'm going to show you in more detail how a platform engineering role on a developer team or elsewhere would go about building one of these. But for now, I'm just going to show you how it works. So I'm going to fire up this app right here. It's a full stack application. So it's, in this case, this particular little demo app is composed of a Quarkus microservice on the back end that uses a Postgres database as its persistence engine. And there's an Angular UI for the front end that integrates with the APIs exposed by the Quarkus microservice on the back end. So it's a full stack app. It's a minimal full stack app, but it's enough to show you what full stack looks like. So here you see, I started up the workspace. First thing I'll point out is this thing brought me right back to the view that I was on when I closed it earlier. So you see I have a terminal open. This is something that is difficult to get on your Windows-based laptop. I got a Linux terminal. Because this is running in OpenShift, it's running as containers. And yes, there was an S on the end of that. My workspace can be composed of one or more containers. In this case, this is a relatively simple workspace. It's running two containers. One of them, the primary one, is the dev tooling container. That's where my Java version is installed. That's where my Angular and Node and all of my tooling and my shell preferences, all of that is in the main tooling container. The second container is a Postgres database. And I can access that Postgres database via a terminal, should I so desire. What you're looking at is VS Code. But it's VS Code with some extra OpenShift frosting layered on top of it. And this is one of those extra pieces of frosting here that I can not only open a shell terminal into my workspace, but I can choose the container that I want to launch that terminal into. And so here I am in the Postgres container that's running. And I can fire up the shell for that database. So now I have CLI access to the Postgres database that's part of my workspace. So my full stack is here. I have my Java backend, I have my persistence engine, and I have my Angular front end. There's more. Because it's all here, and because the engineer that built this workspace for this team planned ahead, you can see I've got a bunch of extensions over here on the left-hand bar that are already in place. I didn't have to install any of these. I didn't have to configure any of these. When I created this workspace, they were all installed for me. Something else that was done as part of this workspace definition was the pre-creation of some tasks that get provisioned as part of this workspace. And so now, as a developer ready to start contributing some code, I can fire up my Quarkus microservice in live developer mode. It's going to build and provision and start running in debug mode. And right there, you see this dialog that just popped up. It says, hey, process HTTPS Quarkus is now listening on port 8080. Do you want to open it? That's because this workspace is also configured so that certain ports that I know apps are going to be listening on can be exposed as routes out of the OpenShift cluster. So say, for example, I'm using Hopscotch or Postman, and I want to do some API testing from my local workstation or from somewhere else. I can interact with the APIs that are running in this Quarkus microservice in live developer mode. I can make live changes to this code and see the results in real time. Not only that, but I got another task here that says, hey, start Node.js development local server. I'm going to run that. And here my Node app is being built, compiled, and started up, also in live developer mode. So now I've got a Quarkus microservice running in live dev mode. I've got a Node app running in live developer mode. And instead of opening that Node app from this dialog, I'm going to come back over here to the Explorer view. I'm going to show you, you see these endpoints right here? These are all of the potential endpoints that have been configured to be either internally available in this workspace or exposed as routes out of this workspace. And there's the node one right there, this node 4200 HTTPS. If I open this, VS Code is going to ask me if I really want to, because that's what it does. It's trying to protect me. And there's the really lame Angular UI that I wrote for this demo. It has two functions, one of which is to invoke an API on the Quarkus microservice to retrieve random thoughts from the Postgres database. You can see I've already got a couple of them in there. The random thought and the unique identifier of that random thought. The second function in this UI is that I can stash a random thought. So it's the C and it's the R of a CRUD app. And so there you are. I have a full stack application. I can test it in real time because I can see the UI, or I can use, like I said, Hopscotch or Postman to interact with the APIs. I can make live code changes to it because I'm able to run the apps and the ecosystem that they need in real time. I can access CLIs. I can access a Linux terminal. And oh, look at that. I'm even logged into the backing OpenShift cluster as myself. And so I can also interact with the OpenShift / Kubernetes that my workspace is running in. How's that for inner loop development? I can write my code. I can see the results in real time. I can debug it in real time. I can make changes, and I can run the entire app ecosystem all in my workspace. And I, as a developer, don't have to configure or set up any of these components. That has to be done one time by somebody who has the engineering knowledge to do that, which may be on the development team, or it might be a platform engineer on a team that is dedicated to platform engineering for developers. But the key here is that I have an entire development ecosystem that is unique to this app project, and I have a bookshelf full of those that I can fire up that are also uniquely configured for the apps that they support. And I, as the developer, don't have to juggle those dependencies. Now, I know there's a ton of questions that this is popping up, one of which is, well, how the heck do you create one of these? I'm going to show you that in a subsequent video. I'm also going to dive into some of the features that you can take advantage of with this, like the ability for folks to be working on different parts of the application, but expose the parts that they're working on to each other. So like if I've got a friend that's working on the front end and I'm working on the back end, I can expose the route from my back end to my friend, and they can connect their front end to the back end, and we can collaborate in real time. They can make UI changes in real time and see the results. I can make back end service changes in real time, and they can interact with those changes without me having to push CI/CD build and deploy iterative instances of the application. I can just run it in my workstation in real time development mode, and they can connect to it. I'll show you a bunch of other really cool things, but the last thing I'm going to show you today is what it looks like for a brand new developer to onboard to this for the first time. So I'm going to come up here and I'm going to switch windows real quick. I'm using a private browsing window so that this doesn't have any pre-cached stuff in the browser, and it doesn't have any cookies from my other sessions. This will give you a view of what it looks like for someone who comes along for the first time. And they log in with their OpenShift account. In this case, it's my puppy dog, Ruby, who, even though she's blind, she does help me write my code, which probably tells you something about the quality of the code that I write. And here Ruby is. Ruby is looking at a empty dashboard. She's logged in for the first time. I will say one little thing. Engineering has already configured this so that Ruby's OAuth is set up with our backing Git repository and all of those things. So Ruby doesn't have to configure any of that. She's already logged in. What Ruby needs is access to the Git organization or repos or projects or whatever it is from the provider you're using, where that project is. And she needs the Git URL of the specific repository in that project that has the magic sauce, which I'll go into in a subsequent video, like I said. In this case, it's called a dev file. This is the thing that actually declaratively configures that workspace. She just needs access to the repository that has that thing, okay? And what she does is she takes that Git URL, she brings it back over here to the dashboard, and she says, add a workspace. And she pastes that URL into that and says, create and open. This is where the workspace is created. It grabs that dev file, interprets it, pulls the container images that are specified for that, sets up the configuration, and once the pod, which is running those containers, is up and running and available, it'll pop her into the IDE. Notice this is the first time, so the IDE is saying, hey, do you trust the authors of the code in this workspace? And you can see over here on the left, the code's been cloned. Ruby says, yeah, this is the person that gives me my breakfast, and so I think I trust them. And so she says yes. That allows VS Code to then configure the setup. You see this little clock that popped up over here? All of the extensions that I mentioned before are now being installed. And so in just a matter of moments, Ruby is going from 0 configuration to having the right JDK, the right version of Node, all of the peripheral components installed, configured, and ready to start building code. And so now Ruby can immediately pop into this environment, even while it's still installing and set up the extensions. And she can run a Maven package. And now imagine there's some really awesome theme music playing as you see the dependencies scrolling by, because that brings us to the conclusion of this pilot episode of OpenShift Outdoors. I hope you've enjoyed it, and I hope you have a whole lot of questions now about OpenShift Dev Spaces, because like I said, for me, it is the greatest thing for inner loop development that I have come across in a long, long time. Thank you for watching.